Hello, everyone, and welcome to Solving Radical Equations. All right, the steps in solving radical equations is to first isolate one radical on one side of the equation. Now, every now and then, you will have two radicals, so you want to have one radical on one side of the equation and the other radical on the other side of the equation if you have that situation. Now, once you get the radical isolated to one side of the equation, then you want to raise each side of the equation to the power that is equal to the index, or the root of the radical. For example, if you have the square root of something, then you want to square each side. Or if you have the cube root of something, then you want to raise each side to the third power. Repeat steps 1 and 2 if there is still a radical term in the problem. Solve the equation, and then check the solutions. And I have that in red because that is a very important step when you are solving radical equations. Make sure that you check your solutions back in the original equation. Okay, so let's look at a few examples. All right, so this first example, we want to solve the equation of the square root of 3x minus 2 equals 5. So as you can see, we already have the radical isolated to one side of the equation. So now let's square both sides because we're taking the square root of 3x minus 2. So to get rid of that square root, we're going to use the exponent square. We're going to square both sides. So the square root and the exponent square, they will pretty much cancel each other out. So on my left-hand side, I would be left with 3x minus 2. On the right-hand side, 5 squared is 25. Now we want to go through our equation solving steps. So add 2 to each side. Gives us 3x equals 27. And then divide by 3. So I get the answer of x is equal to 9. So let's check that answer to make sure that it's true. So in my original equation, I'm going to replace the x with 9 and simplify to see if it makes a true statement, see if the sides are equal to each other. So I get 3 times 9 is 27, and 27 minus 2 is 25. So I have the square root of 25 equals 5, which is true. The square root of 25 is 5, and 5 equals 5, so that's true. So x equals 9 is a good answer. It's a true solution. Okay, so let's look at another example. Square root of 3x plus 1, and then outside of the radical, plus 2 equals 0. Now again, the first step is to isolate the radical on one side of the equal sign. That basically means that if you have something that's not underneath the radical, you want it moved to the opposite side of the equal sign. So let's use our addition principle and subtract 2 from each side of the equal sign. All right, so now we have the square root of 3x plus 1 equals negative 2. Next step is to isolate the radical. Now pay attention here to the radical that you have. Make a note that we have the square root of something, and it's telling me that it's equal to negative 2. Let's go ahead and solve it. So since I have the square root, I want to square each side, raise each side to the second power. The square root and the exponent square will cancel each other out, so that gives me 3x plus 1. On the left-hand side, negative 2 squared, negative 2 times negative 2 gives me positive 4. Subtract 1 from each side. Divide by 3. And my solution that I have is x equals 1. Check your solution. So the square root of 3 times 1 plus 1 underneath the radical, and then outside the radical plus 2 equals 0. Back into my original equation. 3 times 1 is 3, plus 1 is 4, so I have the square root of 4 plus 2. The square root of 4 is 2 plus 2, and 2 plus 2 is 4, which is not equal to 0. So therefore, this is not a good solution. My answer would be no solution. Now, let's go back up here to where we have the square root of 3x plus 1 equals negative 2. That should be no real numbers. Now, remember that we cannot take the even root of a number and get a negative answer. So when we had the square root of 3x plus 1 equaling negative 2, I knew right then that I could not have a real number answer solution. Okay, but you can always work fully through the problem, check it, and then you can determine. All right, what about the fourth root of 4x plus 1 minus 2 equals 0? Again, first step, let's isolate the radical. So let's add 2 to each side. So that will give us the 4th root of 4x plus 1 equaling positive 2. Now this time I have the 4th root, so I want to raise each side to the 4th power. So whatever your root or your index is, that's the power that you want to raise each side to. So the 4th root and the exponent of 4 will cancel each other out. So now I have 4x plus 1. 2 to the 4th, 2 times 2 times 2 times 2 is 16. Subtract 1 from each side. So 4x equals 15. Then divide by 4. I will leave my answer in fraction form. So 15 fourths. So again, let's check that solution. So I have the 4th root of 4 times x, or 15 fourths, plus 1. Then outside of the radical, minus 2 equals 0. All right, so 4 times 15 fourths. The 4s would cancel each other out, leaves me with 15 plus 1. Fifteen plus 1 is 16. The 4th root of 16, well, we just said the 2 to the 4th root, 2 to the 4th power is 16, so the 4th root of 16 would be 2. 2 minus 2 is 0. 0 equals 0. That checks out. So 15 fourths is a good solution. Okay, let's take a look at one more example. The square root of x plus 4 equals the square root of 2x minus 5. All right, so we have two radicals in our problem, but they're on opposite sides of the equal sign, so we're good to go ahead and raise each side to the 2nd power so we can get rid of those radicals. We can clear those radicals. So the square root and the exponent square will cancel each other out on each side. So we'll have x plus 4 equals 2x minus 5. And then we want to solve the equation, so I'm going to move my x's to the left-hand side. 1x minus 2x is negative 1x. Then I will move my constant numbers to the right-hand side, so I'm going to subtract 4 from each side. Gives me negative 1x equals negative 5 minus 4. In the negatives, subtract, so I get deeper into the negatives, negative 9. Divide each side by negative 1 to solve the equation for x. I get the solution of x equals 9. So again, make sure you check your solutions. Back into the original equation, so I'm going to replace each one of my x's with 9 and simplify each side. On my left-hand side, 9 plus 4 is 13, so I have the square root of 13. On the right-hand side, 2 times 9 is 18. Minus 5 is 13, so I get the square root of 13 equals the square root of 13, which is a true statement, so x equals 9 would be my solution. All right, I hope you found this video to be helpful. Thank you.